Hello children, welcome back to my channel. Now I am dealing with ninth class circles. Example 4. Let O be the center of the circle. PQ is the diameter. Then prove that angle PRQ is 90 degrees. Angle PRQ is 90 degrees, that you have to prove. So what is given to us? We have got a circle with center O, and PQ is the diameter. Now what is RTP? We need to prove that angle PRQ is equal to 90 degrees. Now let us go for the proof. PQ is the diameter. This is given to us. Therefore, angle POQ is equal to 180 degrees. So what is angle PRQ? Angle made by the same segment PQ or same arc PQ. Angle made by an arc at the center is double to that of the angle made by the same arc to the other side of the circle. So we can say that angle PRQ is the angle made on the other part of the circle. Other part of the circle. Therefore, angle POQ is equal to 2 times of angle PRQ basing on the theorem which we have learned. So, therefore, what is angle POQ? 180 degrees is 2 times of angle PRQ. So, what is angle PRQ? Angle PRQ is equal to 180 by 2, that is 90 degrees. Therefore, angle PRQ is equal to 90 degrees. Hence, proved. This is the proof of this problem, children. Please note it down. Now, children, in example 5, this is the figure given to us and they are asking to find x. We know that angle AOB is equal to 2 times of angle ACB. This is the theorem which we have learnt. That is equal to 2 into 40 degrees, 80 degrees. Now we know that x degrees plus angle AOB is equal to 360 degrees. The total angle at the center. This is nothing but angle at the center. So, x plus 80 degrees is 360 degrees. Now, x is nothing but 360 degrees minus 80 degrees. So, how much you are getting? 8 here, 280 degrees. Therefore, x is equal to 280 degrees. This is the answer, children. Please note it down. Now, children, theorem 12.4. If a line segment joining 2 points, see, AB is the line segment which is joining 2 points. AB is the line segment joining 2 points A and B. So, this is the line segment, children. And if a line segment joining 2 points subtends equal angles at two other points lying on the same side. For AB, let us suppose this is the side we have selected. Here C and D are 2 points. So when you join them, it is giving same angle. Whatever is this angle, the same measure is angle D. Then uh, subtends equal angle at the two other points lying on the same side of the line. Then these 4 points lie on a circle. 4 points, what are they? A, B, C, D. They lie on the same circle. That means if points are lying on the same circle, we call them as concyclic. What is that they have given? A line segment AB is there, which is formed by joining 2 points A and B. Two more points are taken on the same side. Means either this side or this side. For our convenience side, we have taken it this side. Two more points are there. Now when you join this, they are subtending the same angles. Whatever is this angle measure, same angle measure is this. Now we need to prove that A, B, C, D are concyclic. They are lying on the same circle. So what is given to us? A, B, C, D are 4 points. C and D lie on the same side of AB. This is given to us. Now what is RTP? You need to prove that A, B, C, D are concyclic. That means they are on the same circle you have to prove. So here you have a construction. What is the construction? Join A, B and C, draw a circle to triangle ABC. See, when you join ABC, you are getting a triangle. For that, you have to draw a circumcircle. Already we have learned how it has to be drawn. Now, let us see the proof. Let point D lies outside the circle. Point D lies outside the circle. Then, if point D lies outside the circle, AD intersects the circle at E. If you join AD intersects the circle at E. Okay. Now, if it is intersecting at E, then on joining B and E, if you join BE, angle ACB is equal to angle AEB. Why is it? They are the angles made by the segment on other side. This is a theorem which we have learnt. Theorem we have learnt. So angle ACB is equal to angle AEB. Okay, children. So if angle ACB is angle AEB, basing on the theorem, because this is a sector or arc, we can say arc and subtending angles on the same side should be equal. That is a theorem, basing on that they are equal. But angle ACB is equal to angle ADB. This is given to us. Therefore, angle AEB is equal to angle ADB. This is possible only when D lies on E. Therefore, our assumption is false. D lies on the circle. D lies on the circle. This is the proof for the first figure, children. You have two figures. This is first figure and this is second figure. Basing on the first figure, if the point lies outside, is it true the statement that we have proved only when we considering that D is outside? Say the angle, if D is outside, angle ACB will be equal to angle AEB because they are the angles on the same segment. So they are equal in measure. So these two angles are equal. But they have given angle ACD is equal to angle ADB. That means what? These two angles should be equal. How is it possible? Only when this point lies here. That means ABCD are collinear. So sorry, concyclic. So D lies on the circle because anyway when you are drawing a circumcircle ABC are in cycle only. We are talking about only point D. We expected that it is outside the circle but we have proved that our assumption is false. So we are saying that D is on the circle. If you copy this, children, I will prove the second one also. Now the second part of it. Here, let the point D lies instead of outside, I will say inside the circle. Inside the circle, in this figure, see, D lies inside the circle. Then, if D lies inside the circle, then extend AD to intersect the circle at E. Same we can write. Now, angle ACB, same proof, children. Angle ACB is equal to angle AEB basing on the theorem. But angle ACB is angle ADB. If you join this, angle ACB is equal to angle ADB, this is given to us. So, this is possible, this means angle AEB should be equal to angle ADB. This is possible only when D lies on E. Same, everything is same. D lies on E means what? Our assumption is false. Point D lies on the circle. Therefore, what you can say? A, I'll write it here. So the last point I'm writing here, children. Therefore, A, B, C, D are concyclic. Hence, proof. Please note it down. Now, in this first problem, exercise 12.4, in the figure, O is the center of the circle. Angle AOB is 100 degrees. Find angle ADB. This angle is how much they are asking. Okay, this is the question. Now, angle AOB plus reflex angle AOB is equal to 360 degrees. This is reflex angle AOB. Okay, this is complete angle. Okay, angle AOB is 100 plus reflex angle AOB is equal to 180 degrees. Sorry, 360 degrees. So what is reflex angle AOB? 360 degrees minus 100 degrees, 260 degrees. So this is angle made by the major arc at the center. This is angle made by the same major arc on the other side of the circle. Therefore, angle ADB is equal to half of angle A, reflex angle AOB. Reflex angle AOB. This is what we have learnt in the theorem. This angle at the center is 2 times the angle at the ADB. That means this angle is half of that. That means half into 230. 260. 260. That means how much? 2 ones are 2 threes are 130 degrees. Therefore, angle ADB is equal to 130 degrees is the answer for this problem, children. Please note it down. Now, second problem, children. In this second problem, we have got a circle with the center O. These are the two chords they have done and they have joined through center. Angle BAD is 40 degrees. Now, what is angle BCD? We know that angle BAD and angle BCD are angles subtended by the arc BD on the same side of a circle. On the other side, we can say not same side, on the other side of the circle. Therefore, angle BAD is equal to angle BCD basing on the theorem which we have learnt. They are equal. Angle subtended by the arc on the same side of the segment on the other side of the circle are equal in measure. The angle BAD is 40 degrees is equal to angle BCD. Therefore, angle BCD is equal to 40 degrees is the answer for this problem, children. Please note it down. Very simple one. Now, in the figure, O is the center of the circle. Angle POR is 120 degrees. You have to find angle PQR and PRS. We know that angle POR is 2 times of angle PQR basing on the theorem which we have learnt. Angle subtended by an arc to the center is double to that of the angle subtended by the arc on the same side of the on the other side of the circle. So it is double. Angle POQ, 2 times of angle POQ is angle POR. So what is angle POR? 120 degrees is 2 times of angle PQR. Therefore, what is angle PQR? 120 by 2, 60 degrees. Similarly, we know that reflex angle POR is equal to 2 times of angle PSR. What is reflex angle POR? We know that reflex angle POR plus 120 degrees is 360 degrees. So what is reflex angle POR? This is nothing but 360 minus 120. That is 0, 4, 2. 240 degrees. So Therefore, 240 degrees is equal to 2 times of angle PSR. This is angle PSR is equal to 240 by 2, that is 120 degrees. Therefore, angle PQR is 60 degrees. Angle PSR is 120 degrees. These two are the answers. Please note it down. With this, I am going to conclude my topic today. In the next class, I will be doing the next part.